Good afternoon.
Hello.
All right, it's 12:30, we'll get started. So today is just all strictly review, it's all question and answer. I've been through everything that I wanted to go through. I'm hoping that a lot of you, or at least all of you here, have had a chance to go over the material, to practice some mechanisms, a lot of mechanisms, I hope, and hopefully for some of you, the angels have begun to sing, and you are able to see how the beauty of the arrows. All right, any questions?
I have a question.
Victoria?
Yes.
What's your question?
Yes. My question is, I'm a little confused when to write in a product. For example, when to write what is it called? Side product, I guess. And when to not, for example, in Easter formation, we have the result. And then in some of your examples, you do write HO2. Some of them you omitted.
Okay.
So should we or should we not?
It depends. Now let me, hang on. Right. If it's a situation where you're just looking for the credit, right? You're not looking for any bonuses due to the mechanism.
Okay.
Then all you're doing, all you need to do is put anything that's got carbon in it. You don't have to put any of those other inorganic side products. However, if you're doing the mechanism, then you would need to show those.
Okay.
In any mechanism.
Okay.
But that's my usual guideline, is make sure that anything that's got carbon in it gets shown, and if it doesn't have carbon in it, it's kind of optional to show it if you want just the credit for the question. So I just want to make everybody aware that the test is Wednesday. I just want to make sure everybody understands that. Mm-hmm. All right. Victoria, did you have another question?
Oh, kind of follow up on the same thing.
Yes.
At the alkoxide formation, we get our end product, and the HO2, you're saying that not necessary unless it doesn't have a carbon.
H2.
Yeah.
H2 doesn't have carbons in it, so you wouldn't have to even show the H2.
Okay, that's it. I just wanted to clarify this.
Okay. Any other questions? Otherwise, what I can do is I can go through a test, or if nobody has any real other questions to go through. Rebecca?
I have a fine-tuning question. when a hydrogen that's adjacent to a positive carbon, or carbon that has more of a positive charge is getting involved, and you're showing the hydrogen going to, does it go to the bond or to the carbon, the arrow? Like, where should it be pointing?
Okay, let's take a look. I know what you're talking about here. I'm just going to go ahead and,
Like in a number 2 where you're showing a side product. I mean, there's other ones too, other mechanisms, but.
you know what? I could actually go either way on that, Rebecca.
Okay.
They're both of those arrows are really telling the same story. But the important point is that the arrow must come from the bond.
The bond, okay.
It has to come from the bond. Right, now, that wasn't what you asked, but I'm just saying it has to come from. It must come from the bond. It can go to the bond, or it could go to the atom that has the positive charge on it. Because both of those are valid ways to express bond formation. If you remember, okay. I always said this, that you could always do this for a bond formation, or you could do this. Right? Both of those are valid.
Okay. Okay.
But the arrow must come from that bond. I tell you,
it's a little confusing when I look at the X, the way you have it. It looks like I would put an H there, but you're saying X is the HC bond, correct?
Oh well, I'm just talking. This is just a very what I'm showing you here is just a very general bond formation type situation. I'm just saying it's analogous to what you're asking. I'm not saying it's the same.
Okay.
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 But what I will say is this kind of thing, definitely not.
Okay.
Definitely not.
So, is there one electron that's going from the bond to satisfy that positive charge into the bond adjacent to it? I'm just curious.
Well,
just for my own mental understanding.
Okay. So what I would say about that is that in the bond where the arrow is coming from, there are 2 electrons. Both of those electrons are moving into the new bond. You know, I know you can't see my cursor, so I'll redo that. Now, the issue is that, yes, one of the electrons is being used to satisfy that positive charge.
Okay.
But both the electrons here, one belong to the H, one belong to the C. Okay. Now, one belongs to the C here still, but the C that has a positive charge is getting the other one, and that's why we get the H with a positive charge coming off once the double bond forms, because now the H is missing the electron it used to have. Okay.
Okay, can I state that back to you to make sure I understand it? Okay. There are 2 electrons between the H and C bond.
Where the arrow is coming from, right?
Correct. One electron belongs to the H and one belongs to the C, kind of where your pen is right now. But when there's a positive charge nearby that needs to be satisfied, those 2 electrons go into the bond next to it, the CC bond, we'll call it CC plus. One bond stays with the C. One electron, excuse me. So 2 electrons go into that bond, 1 electron stays with the C, 1 electron goes to the positive charge, and the H is then unbonded and leaves without its electron, which is why it leaves as an H positive.
That's right.
Is that correct? Okay, thank you.
Yeah. Yeah, I think it's really good to understand it on that level as well, Rebecca.
Okay.
Because if you do understand it on that level, then you're much less likely to get anything wrong down the line with it, because you'll be able to think in those terms. I would encourage everybody here to understand it to that level, definitely.
Okay. Well, I think that's why I didn't understand where the arrow was going, because I wasn't exactly sure where the electrons were going. So thank you. I appreciate your time.
Okay. Does anybody have any other test 3 related questions?
It's just either gonna go really bad or really good.
Well, that's the thing. I've always said that this is a bimodal test,
Yeah.
meaning there's a whole bunch of people, generally at least half the class, who get over, let's say 85, at least 85 on the test. And then there's about a quarter of the class who get under 50. Yeah, you wonder how that can happen. Well, it happens because people tend to leave studying to the last minute, feel like they can BS their way through it, think they can make up their own mechanisms, and basically, I think some people say, well, you can't fail everybody. Well, I can fail anybody who doesn't do well on the test, definitely, and I'm not going to lose any sleep over it at all, because I'll know exactly why they failed, and it wasn't my fault. So there's only one thing people can do, and that's just do what they can to understand it and study. Get help if they need it. It's about all I can really say. Sorry, Victoria, were you going to say something else?
No, it's
No.
Rebecca.
Oh, Rebecca.
Victoria, did you have something? I'm sorry.
No, carry on.
Just one other quick question. I noticed in going through the sample tests on the number 1, there are generally, it looks like 10 mechanisms asked, but
Or 9, it could be 9 or 10.
9 or 10. Okay. Are
Because,
there 11 possible though?
Oh, it might be
If you count
13.
ethers as separate?
It might be 13. But, I'm not really going to ask any ether questions, not ether reaction questions of part of question 1. An ether formation question is definitely on the cards, yeah. I mean, I've already stated you will get one of those. But there won't, I can tell you this straight away, there will not be any ether cleavage questions.
Right, because you have a separate question for that.
Yes.
Well, it caught me off guard because I went through all the tests.
No, I know. I know. On the sample test, it looks like there's one there, but no, there won't be. I already, I went through them. There's not going to be one.
I just mean to say I went through the practice tests, let me call them that, not the sample test. And in the practice tests, they were all pretty consistent, but then there was only one that had the alkoxide formation. And so then it just made me doubt, did I have them all? Was there one that was hiding?
Well, I wouldn't say, no, I wouldn't even say the alkoxide was hiding. It just doesn't get asked very often, but it was a possibility when I listed them out a few lectures ago.
Okay, so you're saying there are 13 possibles. The ether cleavage would be in a separate question.
Yes.
So,
I think there's 13. It could be 12, it could be 13, but I'm not 100%
I must be missing one then. Or maybe I'm not counting, I guess I'm not counting the alcohol with the mild and harsh oxidizers. I was counting that as 1, but maybe you're counting that as 2.
I might be, that's possible.
Okay, all right, thank you.
But I do stand by what I had listed as possibilities for question 1 a few lectures ago, which people can go back and look at. I don't remember what date it was, but yeah, you can go back and take a look at that if you haven't seen it. I know you have, Rebecca, but there might be others who haven't. All right, any other questions about test 3?
I have a question.
Yes, Adrian.
So for the dehydration of alcohols, would that be an E2 or an E1 reaction, or does that depend on the alcohol?
It depends on the alcohol, and I will say this. I will do both up here. So E1 and E2. So now E1 is for only tertiary or secondary. E2 you can do for anything. So So that would be my answer to that, but I will do an example here for an E1.
Okay, thank you.
And an example for an E2 as well on the second. Oh, that's a primary. Let's make it secondary. And while I've got your attention, make sure you vote if you haven't voted already. Election day is tomorrow, just in case you didn't know that. I think most people did, but you just never know.
I was so busy with chemistry, I didn't even notice.
Oh, you didn't even notice. Oh, well, go vote if you haven't voted already, Rebecca.
It's done, check.
Is all I would say. You should let me make this symmetric so I don't end up with more than one product here.
Do you realize that you're keeping us from heavily drinking during election day because of this exam?
Yeah. Well, yeah.
You can still drink.
Yeah. I don't know what to say about that.
Post class, no one can affect that. So
Yeah. All I can say is I'm sorry. I didn't really think about it when I made up the schedule. You know, we really didn't have to take test on Wednesday. We could have taken it today, I'm sure, if we wanted to. Although I don't think very many people would be very happy if I said, oh yeah, we're going to take it today. All right, Adrian. So the difference between the two is that the E1 is a two-step process, whereas the E2 is a one-step process. You can see in the case of the E1, we lose the water first and then we lose the H+. In the E2, we lose them both at the same time. But because the E2 can be used for pretty much anything, then I would just go ahead and use the E2. Also, it's shorter.
Okay.
Less to write. That would be my thought. Is that okay?
Thank you. Yes.
All right.
I actually have a question about that because that's confused me all along. There aren't any situations where we have to use E2, I mean E1,
No.
but there are situations where we have to use SN1.
Yes. Now, the reasoning for this is that in the case of E2, it's the hydrogen that's adjacent to the C that ends up being lost, and that hydrogen is typically more exposed. In the case of an SN1, you've got the leaving group here, and the leaving group is connected to something that's very messy. That's why there's a difference between SN1 and E1. So the SN1 doesn't, you don't have a choice. If it's tertiary, it must go SN1. Or I can say tertiary, secondary. For SN2, primary, sorry, I didn't put those in the right way, hang on. Didn't mean to put those in like that. Primary or secondary for SN2. But we don't have any choices there with primary and tertiary. Is that okay, Julie?
Yes, thank you.
All right. Any other questions? I'm looking around here. Anybody got any questions? Not seeing anybody. if nobody has any questions, then I guess I'll just go through an old test. And make sure nobody has any objections. Does anybody have any objections to that?
I have no objections, Professor, but I was just looking through the PowerPoint, and the first 5 or so slides are naming slides. I was wondering,
Yes.
I mean, I've looked at all the old tests and there's been nothing related to naming. I just wanted to clarify that we will not be expected to name any structures on this specific exam.
Correct.
Okay.
But you are expected to do the naming quiz.
Right.
That's due by Tuesday, 11:59 p.m.
Excellent. Thank you.
It's worth 5% of the test.
Okay.
I appreciate the reminder so that
Yeah.
I could tell everybody else that too.
Awesome.
Yeah, thank you.
But my hope was, I always said, to get it done, get it done when I did it. I went through the names weeks ago. So I was hoping that people would just go ahead and do it. I know it's a bit of a pain, but I would rather have done it before and not have to deal with it now when I have to make that horrible choice. Do I do the naming quiz or do I study? That would be a horrible decision to have to make, I think.
So are you going to round the decimals on that naming quiz, or you just get 4.25 or
You get what you get.
the number of points, right? Because that's how you actually calculate the grade.
Well, yeah, but in the grade book calculation, it is literally that grade item plus the other grade item. Yes,
Okay.
but you'll get an extra point for any correct mechanisms you do as part of question 1, and that will be part of your test 3 grade. But that I don't put that separate or anything. The extra credit, it goes straight into the test grade.
Right. Okay. Thank you.
So it's usually routine. A lot of people often get more than 100 points on test 3. I'd say at least a quarter of the class will get more than 100 points on test 3. Pretty amazing, huh? It's true. It's true. Any other questions?
I was looking over the old tests, and I know we went over problem 2 before, but I don't know, it just wasn't sticking with me. Is there any way you could pull up one of the keys and just talk through the steps that are shown?
Actually, I'll go one better because, I'm going to go through a test, right? So I'll just go through question 1, then I'll do question 2. Would that be agreeable?
Yes, thank you so much.
Okay. But it will get done, Sierra.
As long as we make it all the way to number 5.
I don't know if we get, but honestly, Rebecca, I don't know if we'll get that far.
Okay.
If you have something specific for number 5, it's best that you ask it now before I get started on anything. Okay.
I don't. That's okay. Go ahead.
All right. Anybody else got anything else before I start pulling up a test and start doing it?
I just have a quick question.
Yes.
For the bond of say we're doing the roadmap for number 5, I'm looking at an old test right now, but for A, going into A, it's CH2O and H+. I do not remember seeing that before on our previous one, so I'm just not sure what bond that will make.
Okay. Well, let's take a squeeze at that. Sorry, I need to move this up here so I can access. All right, let's try something else then. All right, we'll do that. Okay. Now, if you draw this out, there's only really one possible way that you can draw it out. So, but the carbon has 4 bonds, the oxygen has 2 bonds, and the hydrogens have 1, and that's just like that, Natalie.
Okay, so it's going to end up in a double bond.
End up in a double bond? Well, what was the statement? Was it a Grignard reagent that was starting?
Yeah. Oh, no, never mind. It's just going to replace with OH. What am I talking about?
Yeah. So, if you had something like this, I don't know if it was that, but it was something like it. And
yeah, that's it.
Yeah, that's what's going to happen. Now, you can leave those hydrogens on if you want or not. and then you can join the H plus onto there at the end. But that's a very common pattern that you'll see. And the double bond, will become an OH. That's exactly right, Natalie.
Awesome, thank you.
But I would just add to that, I think understanding that on the basis of the mechanism I drew is going to make life a lot easier for people if they do that, rather than just try to remember that C double bond O becomes a C single bond O. Not saying that's what you were doing, Natalie, but I'm just saying that's what I would suggest for people in general.
Oh, I've kind of made it like a matching game for some reason. It's a lot easier in a sense, for me at least.
Okay. All right. Well, you got to do what you got to do. All right. Any other questions? Okay, I'm going to pull up fall 2017. Now, in many respects, I think for question 1, doing the mechanism where you can is a good idea. But this is what I would say. If you can get the product without doing the mechanism, then by all means, do that first. I do see at times people will sometimes focus so much on the mechanisms and getting them right that it's at the expense of stuff later on that they miss out doing on the test. Now, these mechanisms are only worth 1 point each, and they're not guaranteed if you miss an arrow or something along the way. So going through question 1 first and making sure that you get as many as possible without the mechanism would be advised. At the end of the test, come back and do the mechanisms for those that you didn't do the mechanisms for. So that's just my test advice there. So for this one, for something like this, I think I might do the mechanism because it's a fairly simple mechanism. There's not really much to it. So that, as you can see, this will only take me about 30 seconds to do this mechanism. And the other thing is that if you do the mechanism, you don't have to draw the product out twice. Once you've drawn it, once you get to the end of it, you've got the product. So you've already got the credit. And that would be it. Now, if you're nice to me, what you'll do is you'll circle the answer. And believe me, if I'm happy while I'm grading tests, grades tend to be higher. So try to make me happy. Make my life easy and I'll make your life easy. All right, so that's for the first one. Does anybody have any questions about what I'm looking for here? Yeah, now this one might be a little bit tougher to do a mechanism for, but I'd still be inclined to do it. Be careful and make sure that you include all the relevant details, like this chain that hangs off the end here. And in the spirit of what I was talking about earlier, I would just do a straight E2 mechanism on this one. If you don't include the H plus and the H2O, chances are I'll probably still give you the credit for the mechanism. But again, circle the answer and make sure that all your details are there as well. Does anybody have any questions? Now for this one, this is definitely one I would just use the pattern that I know for this reaction.
There are two products in the one above, correct?
Yes, yeah, you're right, Rebecca. Oh, yeah. Oh, now to
I
get
actually spent some time on this
no,
one.
no, thank you,
Counting.
thank you. I was just, I knew that. I was just testing to make sure that people were paying
See
attention.
if we were really here.
Yeah, no, it's all right. No, you're correct there. Now, but that does bring up another point. If you've shown the mechanism on one of these, you don't have to show the mechanism on the other product to get that credit for the mechanism. That being said, it's probably a good idea to show it on both in case you screw one up, because if you get one right and one wrong, then I'll give you the credit for it. At least as far as the mechanism goes. But yes, you're completely correct. There will be another product. Thank you. Let me see. Yeah, okay. Yeah, so there's a product there. Now, the H2O is optional. You don't have to show that. But you can if you want to. If you're going to do the mechanism, I would be expecting to see that. But that mechanism is very long. And I think I'd be more inclined just to do the pattern for that one. Does anybody have any questions about it? Now for this one thing I can guarantee is that any alkene you get for this one will be symmetric, meaning there'll only be one alcohol product for this particular process.
And it doesn't matter which side, correct? Because
No, he's exactly right. Yeah, because it's symmetric. Yeah.
Okay.
And you know, I'll know. I'll know. It's not like I'm going to prefer one side over the other. And you don't even have to include that hydrogen there once you've drawn it in once. You know, you can just it's still there. It's not like. Yeah, so that's not a bad one to do a mechanism for as well, I think, if you possibly can. If you know what you're doing, you can get them done fairly quickly, I think. All right, any other questions about that one? Okay. Well, this one here doesn't even need a mechanism. But you do need to know that it's an oxidation. And the product would look like that. Now for this next one, do anybody have any questions about it? I'll tell you a common mistake that I see here, especially because I often do like to put these methyl groups here. A lot of times people will think it's a hydrogen or something, and they might put some other product there. So that's just something to be aware of. That is a methyl group, definitely. Now for this one, yeah, I would definitely use a mechanism for this one because it's a fairly confusing structure. So take the Grignard reagent, take the MgBr off, leave a negative charge on it. And then just follow the arrows to draw the product. This is why I think it's so necessary to practice these mechanisms and not just memorize products, because I really feel like in this situation, it really serves you well. Now this is symmetric as well. If you look closely, it's symmetric, so it won't matter which side you attack with the Grignard reagent. So that's what I would do for that one, because I really feel like the mechanism has a real value here in making sure you do get the right answer. Does anybody have any questions? I don't know, I'd challenge anybody to get that right without doing the mechanism. just having memorized what the products are. This is why people fail this test, is because for questions like this, they try to memorize what the product is, and of course they get it wrong. Usually because they miscount carbons and such. But it's much more difficult to miscount the carbons if you do it like this. Anybody have any questions? Now for this one, you don't have to redraw these. You can actually just draw the arrows. I can't draw the arrows on here. Well, can I do that? See if I can get smart about it or not. No, it doesn't look like it's going to let me paste that. I was hoping it would let me paste it. It won't. All right. Okay. But you can just draw an arrow from this negative on the O to the C on the BR, and then an arrow from here. Then you don't even have to, then you get a bonus point. And what did you have to do? You drew 2 arrows. Gosh. Who wouldn't draw 2 arrows for 1 bonus point? Anyway, the product is going to look like this. I'm not going to do that mechanism. All right, I'll do the mechanism. You talk me into it. All right. Stop nagging. I'll do it. Ah, dear. All right. So you can do that, but you can do it on the actual structures. You don't have to redraw them. And the product then, see, the mechanism has helped you get this product. And to get that full bonus point, you want that BR minus there, but you don't have to show the BR minus if you're just looking for the product itself. But if you've already done those 2 arrows, you may as well just finish it off. Does anybody have any questions? Okay, so for the next one, I wouldn't do a mechanism for this one either. It's a very easy pattern. And I would just make that the BR, and that's it. And that's all I would show. Initially, if I have time, I would come back. I'd come back to it. Sorry, go on.
We don't have to put the H3PO4 or
Not to get the credit, Rebecca. No, because it doesn't have carbons in it.
Excellent. Okay, thank you.
Yeah, this MCPBA one, this is one I would definitely not do the mechanism for either. But you have to be cognizant of the stereochemistry. If you've got a trans double bond like we have here, then we need a trans epoxide as the product. Does anybody have any questions? Now for this one here, I think it might be the last one in question 1. I would be inclined to use a mechanism for this one because I think it does help, again, clarify your answer, and it stops you making some mistakes you might make if you were to just not use the mechanism. Now, obviously, I know all these mechanisms, sure. It doesn't take me that long to go through them. It might take you longer, obviously, to do it. But you can see that I don't do all of them. I just do a select number of them. And then if I have time during the test, I'll come back. But I like to use the mechanisms to get the answers to the ones that will help me get the right answers. And those are the ones I did. Does anybody have any questions? All right, so Sierra, I will go through this question 2 here, and I'll go through it from scratch. So the first thing you would do, and you could actually do this on the structure if you wanted to. You wouldn't have to redraw it. I have had people do that before, and that's fine. But I have to redraw this to show you. So the HBr splits up into H plus and Br minus. And, you know, you have to be a little bit adept at copying exactly what you have here. I think I might have, I know I screwed that up a little bit here. You know, put an extra carbon in where I shouldn't have over here. That's something to watch out for. All right, let's try that again. Because these are always going to have two of the same on them, so that's how I knew, oh, I've done something wrong. Okay, there we go, that's better. Let's see, 1, 2, 3, yes, 1, 2, 3. So count the carbons in between. I like to do that as well, just to make sure I've got the right number of carbons. Now, the Br minus, this is primary, so it's going to be SN2. This arrow is pointing towards the C that I'm circling there. Obviously, I did circle. Now it's a little bit hard to see that. And this one, because it's tertiary, will go SN1. And that's a two-step process. And, you know, if you're uncertain as to why one goes one way and one goes the other, you're going to go back to test 2 and re-watch my SN1, SN2 videos to give you the background on that. But there's very good reasons for why they do what they do. But it's beyond the scope of what I'm talking about right here. Yeah, during one of these mechanisms, you don't have to redraw this structure that I'm putting the arrow on here. As long as it's part of the mechanism, you've done it. Sierra?
This is gonna sound kind of dumb, but for this question, are we just trying to pick which ones are gonna be formed out of those given products?
No, all of those products are going to be formed. And okay. It's your mission to figure out what mechanisms are used to get those products specifically.
Okay.
But every last one of those will be formed. So what I've done up to this point is I've done the top row. So all 4 of those.
Dr. Musgrave, I think there's like a crazy amount of carbons.
I was just looking at that.
Well, you drew it with 4 and then with 5 and then with, because the one in the example I think just has 3.
3.
Not including the purple. Yeah,
I think I screwed up to over
okay,
here.
I was just going back through and checking that as you were doing the last part, and I
saw it. I saw it just as you were Just as you were saying something, I said, "Oh gosh, I think I've put too many carbons in here." But you know, it's just a good it's a good guide to the fact that you know you got to make sure. It's hard. Look, it's hard for me to do it on this with this drawing thing. I would.
It's hard for us to watch too.
Yeah, I know.
No, that is something I struggle with, is making sure when I'm attaching something like the BR that I don't underdo the carbon. So I'm trying to make myself count, like you were saying.
I think I've done it. I think I've fixed it now.
Yeah, it doesn't match what they gave us, but that's fine. You just made your own.
Oh,
I
I
started
see.
with one
Oh, I
extra
started
carbon.
with one extra carbon, didn't I? Oh,
Yes.
all right. Well,
But now you're consistent to what you drew, so that's fine.
Yeah, well, all right. Yes, I see what you're saying. All right. No, and then that was a mistake I made because I redrew it, but I redrew it incorrectly from the first one. All right, I'm just going to continue on here. Regardless, I'm going to press on. So these other alkene products come from the alcohols. And obviously that's going to screw up something as well, but we'll get to that in a second. Oops.
So then for that second row of products, you're looking as to which ones it could come from the top row of products.
Yeah, now the alkenes, it should be pretty obvious to which alkenes come from which alcohols.
Yeah.
The ones with more carbons in them tend to come from the SN1 the SN1 process reaction. And you know, you can't do the mechanism on the same thing, so you have to redraw it to get the other product. Now the other one is going to be inconsistent with what I've got on the screen here, but that's because I've used a different alcohol. But I'm still going to do it using what I've got in my answer. I think I might have to close my door. There's a lot of noise going on out there. It's better. Why people choose to do this crap while I'm working. Damn inconsiderate. Just kidding. Just kidding. All right. This is one that has to be E2. My internet connection is unstable now. That's not nice. Now, did I? No, I screwed that up again. I'm going to erase some of this stuff here. Problem is I was trying to draw it small and that ended up. Let's try that again. We'll do it properly here. There we go, it's better. There we go. And remember, that doesn't match what's on the slide because I have an extra carbon up here on this side. All right, does anybody have any questions? Sierra, you had asked about this.
Yeah, it makes more sense now. I was just like, wait, how is that one thing forming all of those things? But it makes sense now. You have products coming from the products. Basically.
Yeah, you can't get those alkenes in one step really. Does anybody have any other questions about number 2?
Sorry, did you hear what I said? Computer's cutting out.
Yeah, I heard what you said, Sierra.
Okay, sounds
But
good.
but it didn't sound like a question, it sounded more like a comment to me.
Yeah, it was, I got it now.
Apologize once again, I didn't see how many carbons were here. So question 3 is a synthesis type question. And for that, you can use reactions that you've already got the answers for as part of question 1. Now, the structures won't be exactly the same, but what I can tell you is that it looks like this. The answer will look like this. You need to find A, B, and C. So in this instance, let me see. I wonder if I can pull up the key for this. So what you'd be looking for is something that has this product or a product that looks like this, has the same functional group. And when you look through, there's only one that will do that, and that's this one that has the MCPBA. So you see what the student has done here, you can see that they've even sort of drawn this on the reactant because they know what the pattern is for the MCPBA process. So from here, you can automatically know that it's going to be this situation. So that's kind of like B and C fixed up And then you're just looking for a process that will allow for the conversion of an OH to a double bond. And you would look back through there and see if you can see anything that starts with an OH and ends up with a double bond, and there it is there. So it's just H plus. And that would be the answer for number 3. Does anybody have any questions? Now, obviously, you're going to have trouble with number 3 if you've got number 1 wrong. I'd say that that's probably true. Okay, question 4. Now, I spent a lot of time on this in class, and I gave you a lot of tips as to what to do with this, because it's always going to be something similar to this. But the key is knowing where the OCH3 has ended up in the structure. And you'll notice the student's written SN1 and SN2 here, and that's because in the acid one, it always ends up on the busier carbon. You know, if we're looking at what I'm talking about with busy and not so busy, I suppose. So this would be busy on this side, tertiary, further SN1. And this side is essentially primary, which means that we're looking at SN2. So this is going to predetermine the number of steps we're going to see in each of these processes. So I guess I'll just go through and I'll do it. Now this is one that people like to make up their own mechanisms for, and they'll try and join steps together. And, you know, I don't think that that's the right course of action here. They'll think they can shortcut it. And generally it's because they've tried to memorize it rather than understand it. But I'll know. It's difficult to get right if you're just memorizing it. That much I can say.
Is that arrow going from the HO bond to the O?
It is, yeah.
Yeah,
Not to the bond.
Okay, yeah, I figured.
All right, so that would be for the top one. Now for the bottom one, the bottom one is fewer steps. And because it's primary that's being attacked, it's going to go SN2, which is 1 step. And that is going on to be O that time, Rebecca. And that's for the other one. As you can see, it's a lot simpler because of how, and you know how it's going to go because of where it's attacking. And you know where it's attacking because you already have the products in front of you, so you know where the OCH tree has ended up, and that's really the gist of it. Does anybody have any questions about number 4? And I've already been through this version of number 5 already, so I don't really want to go through it again.
Sorry, I have a real quick question about question 3. I was just wondering if checking your work, like you see on all these practice exams, is required to.
No,
Okay.
I'm just interested in the answer I had. Where you figure out A, B, and C. That's pretty much it.
Awesome, thank you.
Now we'll answer questions about number 5 here. And so somebody was asking about it. Who was it? Who was asking about number 5? Somebody was. Rebecca, I think you might
I
have.
mentioned, yeah, that I wanted to see it done, but it's fine.
I already did
Have
it.
a specific question. Yeah.
I've done it before, but do you have a specific question about this one?
No, not at this time.
Okay.
You may get an email later.
All right. All right. When I went through these, I went through all of them. The main focus I had was that you could either go forward or backwards. And for this specific one, I remember specifically I did it backwards. I figured out what D and E were, knowing that PCC was used from B to C, which allowed me to figure out those were ketones, and I could figure out what ketones they were by knowing what was added with that Grignard reagent. And then I could figure out B and C because I knew what D and E were. So that's one way of doing it. The other way is just to go straight from the beginning and get through to the end that way. But there's always more than one way to get to the end with these. All right, does anybody have any other questions that they want to ask about test 3? Anything that's sort of come up as I've gone through them?
I have a question, but it's on the synthesis roadmap practice worksheet.
Okay. Now, see if we can get to that point. Synthesis roadmap worksheet. All right, so this retrosynthesis problems here, this one?
I think so. Yes.
This one here, okay. Do you remember what number it was?
On number 10, I made it a double bond instead of an epoxide.
No, it has to be an epoxide. And the reason for that is because the thing that's reacting with it is the MGBR, the Grignard reagent. Now I'm going to show you something here. I just have to find my thing here. Okay. See here, this is what has to be. This is the key to recognizing what's going on with this. And that is recognizing that this got added. Are you okay with that, Deanna?
Yes.
Do you see where it got added as well? Look at what I'm pointing to relative to where the OH is.
Oh, is that why on number 7 it became a double bond?
A double bond, oh yes, because it's attached. Let's see, because it ends up attaching to the same C with the O.
Okay.
I think that's what you're getting at, isn't it?
Yeah, that's why, because I was trying to figure out why that one was a double bond O and then that one turned to epoxide, but I didn't take in consideration of which carbon it was attached to.
It's very subtle, isn't it?
Yes.
Yeah, because you can see here in the pattern how we end up with that situation. And then if it's like it is in number 7, then you can see how that ends up on the same carbon.
Right.
Yeah, that's a good question. That's a good question, but yeah, that's the reason.
Okay, thank you.
All right. Anybody have any other questions? I liked that one. That was a good one. Well, look, if nobody has any other questions, then we'll call it a day. And I'll wish you luck. I'll get everything set up. People with accommodations, it'll be the same situation as it was with test 1 and 2. All right. And for everybody else, I'll expect to see you there. You know, same arrangements as before.
Do you open at like 12:20? I forget. 12.
I think I did 12. I think I did 12:20 last time. Yeah. I think I'll probably do that again. So pretty much the same arrangements as last time. All right. Any other questions? All right. Well, we'll leave it there for today then, and I'll see you all later.
Thank you.
Thanks for
Have a
coming.
nice day.
Thank
Thank
you. Julie, Sierra, do you need something? Julie, Sierra?